but we describe it like
no 係 Hong Kong IT 開會，我代表 CIC 咁。
Hong Kong Advanced Technology Lecture Series. I'm Vicky Liu. I'm EXCO of AIA Hong Kong chapter. So welcome to tonight's event. So this is a three-part lecture in the series, and tonight we will focus on technology and materials. And I just want to ask anyone here coming to AIA events first time, raise your hand. Wow, like 40% of the audience. So welcome. So I hope you enjoy and definitely come back for more. So before starting our lecture, I would like to give you an update of what's new at our AIA Hong Kong chapter. The theme of our chapter this year is Young Architects Initiative. Young does not mean we will check your ID before you come in here, but also the new perspective, new techniques, new processes, and new energy that the next generation brings to the profession. And collectively, we will break new ground and make architecture better and better. And tonight's lecture on the advanced technologies is formulated in the same spirit. So, and just last week, we have convened the Young Architects Forum, aptly titled Emerge with an exclamation mark. The forum focuses on emerging talent. And we have 6 firms, young and already garnered international attention, coming to speak to us about their work and their approach to architecture. The firms include OpenUU, SQ in Hong Kong, O Office from Guangzhou, Design Trademark from Beijing, OBBA from Seoul, and Super Machine from Bangkok. It was amazing. So if you missed it, I still have some of the beautiful conference poster, and so definitely talk to me and you can have one. And also keep an eye on any upcoming magazine articles on this event. And in the same spirit, in our first quarter meeting, we were honored to have Li Xiaodong, the first winner of RAIC Moriyama Prize, speaking about his exemplary work related to context, materials, community building, and about forging a new path of new Chinese architecture. And we also had a very moving ceremony on the new elevator fellows in our chapter. Sean Chow had just become FAIA, and there are now 7 fellows in Hong Kong. And earlier in February, Pritzker Prize laureate Dong Ming was in Hong Kong, and this lecture was held at Chinese U. And we also had a workshop with professional coach Teresa Norton about engaging clients. And the event was held at the Lincoln office. And since we are architects, we also go look at buildings. And it was a visit to St. Andrew's Church Life Center by Nelson Chen FAIA. And last month, we went to Asian Society and get to know more about the behind story of these amazing buildings. And these 2 projects are both honor award winners of our H&A program. And if you worry about we architects getting too serious, sometimes we get together just to party as well. And this is a snapshot of our New Year kickoff party. And we have more social events planned for this year as well. And we have more events planned to end of the year, and including next month, our chapter will have a 12-people delegation representing Hong Kong at the AIA convention in Philadelphia, including myself, John Sallery, and Christine Bruckner. All of us will go to the stage representing Hong Kong. And if you want to join our delegation, come talk to us. And in June, we will visit King George V School by Ronald Yu and Partners. That's also an honor award winner of the Hong Kong chapter H&A program. And we have 2 more lectures planned in this advanced technology series. including one about technology and design, and one about technology and production. And next week, we will focus on material. We have a lecture about leather, how it is being made in processes and what makes it a sustainable material. And I'm proud to say that AIA Hong Kong chapter is an organizing partner of the upcoming CTBUH conference on tall building. It will be held in Hong Kong, Guangzhou, and Shenzhen. As AIA members, you are entitled to advance discounted registration. So definitely do that. So with that, I will pass the stage to Jason Carlo. Tonight's event is organized by him. He is the chair of our Advanced Technology Committee. And he is also program director of the master program at Hong Kong U. So please welcome me in welcoming. Please join me in welcoming Jason.
Hi everyone, and welcome tonight. It's great to see so many familiar faces in the crowd, present colleagues, present students, former colleagues and former students, as well as associates and friends from AIA. And thanks again to Herman Miller for organizing and sponsoring the event tonight in their fantastic showroom and sponsoring the food and drinks. It's a great setting, and I'm glad that tonight will be a kind of a half lecture, half seminar. So we're very happy to be here. Thank you very much. Thanks also to Ken Howe, the president of the AIA Hong Kong chapter, who couldn't be with us tonight as he's in China on business. Ken asked me to put together this lecture series on technology last winter, and I'm very excited and happy to do so. I came to Hong Kong in 2006 to teach at HKU, and I've been very interested in the relationship of technology to architecture and the way that it changes the way that we practice, the way that we communicate with each other, our clients, our contractors, the way that construction documents and legal documents fly through the ether in ways that they never did before. And I was kind of teaching, I was in graduate school and architecture school in the kind of turn of the century, between the time of the paperless studio, running in schools like Columbia University in New York, and perhaps on the threshold of another era of digital architecture that is dealing with material more specifically and material behavior. So the first, as Vicky said, the first lecture in this three-part series is dedicated to the relationship between technology and materials. This is not a new series. In the past, we've had an advanced materials series, and I think that you can't remove the idea of materials from tools or technology. And in the past, we've had speakers telling us more about things like graphene and smart concrete. How do I advance? Some members of the audience tonight, like Martin Rees from Front, gave us a talk a couple years ago about facade systems and production technology. Next. I gave a talk, actually Christoph gave a talk as well, about design research and digital technology and materials and its use in design.
Jason, the advance is now.
Oh, here, thanks. But tonight I'm very happy to have three speakers who are not only friends and colleagues, but really individuals and architects who are pushing the boundaries of technology and material. And we're lucky to have all three of them here practicing and teaching in Hong Kong. The first is Christoph Krola. Christoph is a professor at the Chinese University of Hong Kong, as well as the founding partner and principal architect of LEED, the Laboratory for Explorative Architecture and Design. Christoph is going to talk to us tonight about his work with bamboo and the pavilion that was recently completed outside of the Zero Carbon building for the Construction Industry Council. So he'll be talking about digital techniques of modeling, measuring, analysis, and fabrication of a very traditional material that we're all, I think, well aware of and its importance to Hong Kong construction. Olivier Autevert, who's a colleague at the University of Hong Kong and the principal of a design studio called Double O Studio, has been working on, in his small office in the corner of the 4th floor of the Knowles building at Hong Kong U. He's turned into a fabrication laboratory and has been funding and sometimes self-funding the most amazing concrete fabrication processes using manual and digital modes of design, innovating in terms of casting and form making, again with digital and manual techniques. So we look forward to hearing about a bunch of his work. Olivier's design career has been looking at concrete and its use and innovative uses for that material over a number of projects. And tonight we're looking forward to hearing more about the towers. He's also an award winner from the World Architecture Festival held a couple years ago for a project called The Pinch, which is also published by the AIA recently in Architecture Magazine. And finally, Mark Bullhart is here with us to represent Awawa. Mark and his partner Roberto De Bolio have founded and formulated an amazing fabrication and design and firm that exists on the periphery of architecture and fabrication. They've partnered with a factory in the Pearl River Delta and regularly go back and forth. So regularly, in fact, that Roberto couldn't be here with us tonight because he's working on an emergency project in the factory, CNCing wood as we speak. So we're very happy to have Mark here. And so this work is relating to the material of timber and the technology of CNC milling, which is linked back to actually lots of expertise in terms of carpentry and joinery, bridging the gap between, again, digital and traditional. So we'll have speakers present in that order, Christophe and Olivier and then Mark. And at the end, I think we'll have time for a larger discussion and a Q&A session from the audience. So thank you very much, and I'd like to introduce Christophe Crowley.
Okay, good evening everybody. My name is Christophe. Thanks Jason for the introduction and thanks AIA for inviting me over here. I'll be talking today indeed about the ZCB Bamboo Pavilion. The title of the lecture is While Your Robots Were Dreaming of Electronic Sheep, or the Protocol of Error. I wear two hats. I'm at the Chinese University of Hong Kong and I have my office lead. This is a project that was done at the university, but it builds up on research that's been migrating between both entities. It's partially funded by a GRF grant that we got from the government, so thank you, government. The lecture will cover the topics that every architecture lecture usually covers. It's about form, structure, materiality, and nowadays computation tools, people, and craft. And it's specifically focusing on what this means in the context of Hong Kong. I used to work for Zaha Hadid a while ago, where we had insane budgets, amazing fabricators, fantastic consultants. And arriving here, I was stripped of all of that. We need to find a way how to adapt to the context where I was working, where I did not have all these means directly at my disposal. And there are two ways to respond to that, either by stripping or adapting. And in the past 5 years, I've been focusing on how digital technology, and specifically computational power, when applied in a very strategic manner in a specific construction process, can allow you to fundamentally overhaul the design solution space that a specific material allows you to have. So what I'll be talking about today is what that means for bamboo, which is, as you know, a very fantastic material, but it has never really been used in the way as I'll be talking about it today.
The deluge waits another forest inhabitant. This one is particularly astounding in its vigor. can grow up to 1 meter a day, fast overtaking the other plants around it. The taller it grows, the faster its growth rate, so that in a matter of days it towers above the undergrowth and continues reaching for the sky. Not bad for what is essentially a grass. It's bamboo.
So bamboo is this fantastic species of a grass. There's over 1,200 all around the world, 750 in Asia, and it grows all over the world except for Europe or North America. And it's something that Asia associates its culture with quite a bit. But for a very long time, it's always been a poor man's construction material. And for that, it's been neglected within the construction industry in Asia up until recently. Within Hong Kong, as you know, all of these skyscrapers are actually built with a bamboo scaffolding, which is a very unique and simple construction system where body measures and simple rules of thumb are used to generate these grid-like structures to encompass buildings of any shape or any size. As you know, it's also used for Cantonese opera temporary theaters, where buildings like this appear in various scales and sizes. But it is limited in how it can be used because it relies on these fixed typologies and body measurements. So the only thing that you can really do is scale it up until a certain scale, and then the system fails. It doesn't work anymore. So a while ago, the Construction Industry Council in Hong Kong, which is the organization that's, amongst many other things, in charge of the training of labor in town, of construction workers in town, and therefore also the bamboo industry, they asked us to see if we could come up with a new bamboo installation that would make bamboo sexy again, because their industry had been really lacking interest from younger people to join, although it's a very well-paying industry, I must say. So the zero carbon building is a building in the background, and they gave us a side in front, and that's the installation that we made. So as you saw in the video, bamboo grows incredibly fast, up to 20 meters in a month, and then it thickens inwards. So unlike a tree which grows outwards, it actually goes inwards, and its cellular structure and its pipe geometry makes it an extremely efficient use of, makes it into a plant that extremely efficiently uses its material. The downside is that similar to Burgundy wine, if you grow it on different terroir or different terrain, or if you have a thunderstorm or lack of nutrition or too much sun, bamboo will have a different strength. So it is a very unpredictable material, the diameters change, so it's very much irregulatable, almost, one could say. And that's one of the reasons why it is not regulated in Hong Kong at this point. So all these bamboo structures that you see, you'll have a bamboo master or seafood who signs off on it and takes full liability of the whole thing. When you start to make publicly accessible structures, it's a very different story. Well, I can talk to you about that afterwards. So usually in architecture, for this and many other reasons, it's often either used for its symbolic value or as a decorative piece, or directly as a replacement of steel or wood beams in a manner that doesn't really use unique properties of bamboo, which is its flexibility, its ability to just always spring back up. Now, with digital techniques, it's very easy to simulate that behavior. We can take a curve and straighten it out, or we can see how a curve would behave if you would bend it, or how a network of curves would behave if you would bend it. So we started to work with the integration of these design tools in the design process here. These are all the models, digital and physical, that we made before we actually ventured into construction. One of the reasons being that there were no regulations for that. We need to figure out the hard way how we could actually work with this material. So it started off with a design workshop at the Chinese University of Hong Kong, where 4 groups of students were working on a series of prototypes, where from the very beginning you see here where we iteratively, using real bamboo splits, tested out until we found a system that was actually strong. This system was then taken on by my team and turned into the first digital model, where we started off from the site, placed 3 circles, which would be the foundation points, made a diagrid that was based on that, then extended that diagrid out, which we discovered after a few iterations how to do it, and then used these real-time physics simulation engines to bend that whole system down onto itself and fold this flat geometry into a triangulated cupola structure that had 3 cylindrical column legs coming down to make it into a very stiff and stable hyperstatic structure that had triangulated areas, squat areas, and even just free hanging areas as you see there. To move forward, we first made a prototype 1:30 scale, which is this one, which pointed out to a few difficulties in terms of trying to weave the bamboo, which is not possible. The poles are so stiff that in their entire length they can easily be bent, but in a small scale you can't. So we had to change the installation sequence of these, which I'll show you in the second digital model. So after some testing, we figured out what the most appropriate way was to position all these poles one by one onto the scaffolding without ever needing to weave them too much through one another, but to really still create this very elegant structure. Then we made a 1:4 prototype on the rooftop of our school. Here we purposefully use rattan, which is also a grass-like plant, but this is solid, it's much more flexible. And we made this model to figure out where it would fail and to test where it would fail structurally, and to test if the installation sequence would work. So it is very strong, you see me sitting on it here, but here at the bottom areas we found some weaknesses that needed taken care of later. But the system was a proof of concept, so we went ahead with the construction soon after that. We made a new digital model that integrated all of this. So here you see the final design. It's a 350 square meter covered area. 200 people can sit inside it. The largest span is 37 meters, which is quite sizable, and at its highest point, it's over 4 stories high. Here you see what the skin would do at night to become a translucent lantern. We made a few more prototypes on 1:20 scale to fully test also all the lengths and all the to fully test all the lengths and all the overlaps of all the tubes. And then once we had that, then we went ahead for full construction. So the bamboo we selected is called Mao Zhou. It's one of the giant bamboos that we have in China. It was harvested just across the border in a bamboo forest in a very manual way. These were all shipped in Guangzhou to a central collection area where we started off by filtering out the poles that were most suitable. They were treated with a boric acid solution, which basically only replaces the sugars inside the bamboo. And because of that, bugs no longer attack it. If they do, they literally die on the spot. So it becomes more sustainable over time. So here you see these bathtubs where we submerge the bamboo for 24 hours. While this was happening on site, we started casting the concrete foundations. And these are relatively thin slabs. We're talking about half a meter thin with a little vertical fin to prevent the whole thing from sliding out. These weigh 100 tons. The whole structure itself above, bamboo and fabric, weighs only around 7.5 tons, so 7% of these thin foundations. The air that is covered by the pavilion weighs 4.5 tons. So our structure is only a little bit lighter than twice the weight of the air underneath it. So these concrete slabs are therefore ballast in case of strong winds to prevent the whole thing from just flying off. Such a hyper lightweight structure is this one. We had to come up with a very basic but clever detail to anchor this bamboo structure down. So we borrowed from other countries and advanced them a little bit. This detail where starter bars would just be bent and then cast inside the bamboo pole, using the relief that you have on the inside of the bamboo pole to create a strong friction between the non-shrink grout and the rebar that would be inside of that. That's a very simple detail, but the way to install it was quite fun. So here you see standard foundation, standard casting, very manual. Those are the starter bars. And then to bend them into place, from our models we just cut some paper triangles and using a steel tube. They were bent until they were close enough to what it was that we needed. And then we ended up with all the rebar in that position. For the little plinths that we need to have at the base, we just cut sewage pipes up to a specific angle. The reason was that bamboo cannot be wet. It cannot be exposed to rain or to direct sunlight, UV light, so we had to make sure they were lifted off the basic socle in a similar way that in Chinese temples you would see the wooden pillars also standing on a stone plinth. But here, all these sockles had to be parametrically different according to the angles that we needed. But again, a very low-tech solution was found to to just make these manually, creating a very elegant outcome with a simple Boolean operation manually deployed on site. No need for digital fabrication. Then the bamboo arrived. We cleaned everything nicely, we sorted it, we covered it from sunlight, and this is the final bamboo structure. So we have 473 poles, around 3 kilometers, all different diameters, 12 to 15 at the base, 8 to 12 at the top, all different lengths. And we, of course, had in our digital models direct control over all the intersection coordinates of all of these poles. But the people that were making these were scaffolders that usually never work with plans, never work with drawings, and use body measurements. So we had to work with them, not speaking the language, still finding a way to make these mappable into three-dimensional space. So we came up with a system where all the poles would be numbered, which you see here. We just put a little sticker on them. And then we made a very long table from bamboo on which we put a long ruler, and all the overlaps between the bamboo poles were marked up. So here you see the black nylon wires that you see all around Hong Kong after construction has been finished. Those are the usual ones that they use. We replaced them with steel wires because of fire safety issues. And here you see how we turned one pole eventually into up to 40 meters long pole. These are the only construction documents that we really needed, which was a ruler and then a marking of the labels that would point out the intersections between these poles. So with a simple ruler, a marker, and an accuracy of, I guess, 5 to 10 centimeters tolerance, they marked up the poles. In parallel to this, conventional scaffolding was going up, and then we hoisted the poles up onto the scaffolding by hand. So here you see how one big pole, 20 kilos each, once it's all interconnected, becomes flexible like a little twig. Once these were hoisted up, they were slid over the foundation points. And then here on the ground, you see where we have projected the XY location of a few key intersection points. Those were mapped up vertically, and the first 9 poles were positioned as accurately as we could. At that point, the bamboo was not yet springing back into shape because the intersections were so sparse. But as we kept on adding more and more parts, sliding them over the foundation and slowly connecting them on the top, the structure slowly started to find its own form and define its own shape. Here you see 2 parts being connected just by manual force. We cold bent them on site, and then using very manual techniques, they were brought as closely to the points that they needed, and then just hand tied. Here you see the curvature. Here you see what one point in a 3D model is. So that becomes a 20 centimeter deviation in all possible directions. Here you see us wrapping up the final parts of the structure. Then the foundation. So here you see again tolerances. This pole turned out to be 10 centimeters short. No way that we could pull it down further. So the first thing we needed to do is pull the poles into position so that the rebar was nicely centered. And we drilled a little hole in the side with the plastic sleeve to prevent it from splitting. And then we taped off the bottom. And then we developed this very bizarre technique where you basically jerking motion squeeze non-shrink grout into the bamboo poles until it covered the rebar and was available at the top. Here you see that we removed the base, so a very clean detail there. Here you see the different members coming down, and then all we had to do was seal up the holes, and that was it. Then we had to release the structure from the scaffolding. I mentioned the 1-to-4 prototype that was showing some weaknesses. Our greatest fear was that it would buckle inwards at the legs and would not make a synclastic curvature. So the way we did it is we put some steel reinforcement scaffolding at the 3 legs here. First released the top to make sure that it was buckling outwards, and then released the whole structure, but there was quasi-zero movement. So the whole structure was extremely rigid in and of itself. And so here you see it being released from the supports. The steel ones are still there. Then we finished off all the sharp edges because we had to move towards the sun, the skin. As you remember, this was the hottest summer Hong Kong had ever seen, which was a very brutal working environment for the people on site. One of the downsides was that the differential heat inside each pole from the sun on top and the shade at the bottom was so high that we started to get a lot of splitting happening naturally through the poles. But luckily, because it's a hyperstatic structure and it's just tied by hand, we could very easily replace the poles as we were moving on. So that's the bamboo structure completed. The next thing we need to do is put the skin on. This is a 910 square meters tailor-made suit made from a glass fiber reinforced composite membrane that's consisting of 1,278 triangles. Now we thought originally that we would be able to just extract that information from our digital models, create unrolled strips. Of course, when you have 20 centimeters variation on site, that's not possible. So we had to measure the whole thing by hand. Now, the fun thing there was that we discovered that although we're working with the century-old techniques, all these people had smartphones in their pockets. So we made a Google Doc spreadsheet in the cloud, and then they all shared it. And they just measured dimensions by hand and punched them in one by one. Then from all those, we regenerated the triangles, we made the strips, and basically first made a test model to see if all the measurements were done, the patterns were done correctly. This is one of the few on-site construction drawings actually that we used. Then we went across the border where we found a little village where they had the largest CNC cutting machine I've found so far, which is a very basic machine. It just has this little cutting wheel and a marker where you can draw things with. They had a hacked version of 2007 AutoCAD. And so we nested all the triangles into the most optimal layouts so that we only had around 10-15% material loss. Rolled out the fabric, the CNC cutter went over it. They manually labeled all of those with little stickers. And then they had a team of migrant workers migrating within the city, the little village actually, just putting the edges together that need to be together with super glue. Then they put it underneath this basic welding machine where they fused all these things together and basically turned it into one giant sock that was then shipped to site. This sock was hoisted onto the pavilion, and then they slowly started to unroll it. So when I asked the contractor, like, you're sure about the orientation that it works? Because it's a quasi-symmetrical building, but it's not fully symmetrical. The legs are different in lengths, and they're like, Gustav, of course, we saw where the longest leg was in the factory. We said that's the longest leg. It's going to work. And then we start to see that in one leg you're like 2 meters short, and at the other one you have too much fabric. But this is a structure that is full of parts poking and sticking out. And this is, although it's a glass fiber reinforced fabric, this is a nylon stocking. You cannot just pull it off without having ladders running through it. So that was a problem. And then a black rainstorm came, and the fabric, we couldn't tension it. And so we had these triangles of 2 meters diameter that were catching 70 millimeters per square meter per hour. And in a full panic, these big bubbles started to form. The people on site, well, my guys ran in to try to push out the water. Construction workers all ran inside until they saw how bad the problem was. Then they came out with knives and started stabbing the whole thing. So we had a bit of damage and we had a few tears, but luckily nothing too bad happened. So we immediately had to temporarily prop up the structure from the inside. And the next day when it was sunny, we took this bizarre photo, the World War Memorial. Then the fabric had to be removed. And you couldn't pull it, so we slowly started to roll it up with a team of people. We carefully watched where the wind was coming from, because this is a very big sail. So in the morning we rolled it up on one end. Everybody went very smoothly. Everybody broke for lunch. 3 guys came back for lunch early and decided, well, that went rather well. Let's continue with the next leg. But the wind had turned, and slowly here you see the wind catching the fabric. And it's going bigger and bigger. And if you know the site, there's a big crossroad just on the left. And that's around when my guys came back. And eventually it went so high that the whole fabric was pulled up and it crashed down back onto the structure, impaling itself on the scaffolding around it. But it sped up the removal procedure quite a bit. So we spent some time that day or those days after that, to fix all the tears and punctures. You probably won't find them unless you know really where they are. We took over again, we carefully measured the most important triangles, and we lifted up the whole thing again, carefully positioning it, and the second time it worked. and it fit like a glove. We had to be very quick to tie everything down because Mujigai was coming, and that photo here was taken a few hours before the day before the day before the night when the typhoon hit, and so we quickly tied the whole structure down, quasi-tightened it down, and this is a photo that the structural engineer sent at around 2 o'clock in the morning, and luckily it withstood, so we were fine. The last thing that we had to do was just fix the fabric to the structure itself, put tension on the whole thing. So here you see the simple basic turnbuckles, pull the whole project down, nicely taut skin here, and then we removed the scaffolding underneath. And for the first time we could see the scale of the whole project. And the last touch-ups that were needed were the seams, where here you see the tension seam at the belly area. We made doorways in there, and here you see the whole thing nicely cleaned up. The lighting was installed, where we just used indirect lighting to shine at the top and illuminate the area below. That's just to give you a sense of scale, how big it is, because you don't really get it. It's the most amazing parkour site you'll find in Hong Kong right now. You have to break into the doors. So that's the final completed project, mid-October, and you see how it's a very, very small project sitting around these giant buildings around it, but what it does, it creates a very nice shield that brings the wooden deck that you have there on a much more human scale of the park around it. It's been used for a whole series of events. This was our opening. It's been used for a whole series of events, and I think I have a little video coming up in a bit. That's the view from underneath, where you see how it's shielding off the towers around it. This is one of the zero carbon building events that they had recently. We did do a 3D scan of the pavilion to see how close we were to the digital model. Not that it mattered, because it was meant to be something that would find its own shape. But interestingly, we found 2 areas where you see a very large deflection of over a meter taking place. The reasons for that being that 2 of the 3 members were almost straight, and they straightened themselves entirely out without the 3rd one having force enough to actually keep the curvature in there. But the whole system was still synclastic in its curvature, so we're not really worried that anything bad's going to happen. It's still there in perfect shape. For the drone photography.
Thanks very much, Christoph. I think we'll hold all the questions for the end so we can have more of a discussion and conversation. And now I'd like to introduce Olivier Artubert to tell us about his work with concrete.
Good evening. Thank you, Jason. Thank you, DIA, for the invitation. Jason asked me to present a few projects that I've been doing recently concerning concrete. The title is Concrete as Process, rather than simply concrete as material, which means for me everything that comes before, the whole anticipation to the casting, which basically is formwork design. The bulk of the presentation is going to gravitate around this recent project that I've just completed the physical part. You may have seen that at the Hong Kong Biennale last winter. This is 3 concrete columns of a series of 9. called New Orders, in search of a new point block diagram for Hong Kong. I will get back to this project, but they operate at 2 scale, at 1-to-1 scale, and it's about prototyping methods and techniques of formwork, and also the speculative at 1-to-100 scale of point block towers. But I wanted to begin with an older project that was achieved with students from HKU. It's an offshoot from a more collective called Making Ways and Ways of Making, and it speaks a little bit of an aspiration that I have with the material, which is trying to find ways of basically accentuating ideas of continuity between tectonic elements and fluidity with the material. So I wanted to start with this interesting quote by Jean Prouvé, speaking about concrete. I'm worried by what is done with new material, or rather what is not done, because it can flow. It seemed to me that concrete should give rise to very different articulation, more closely related to the requirements of living volumes. So we try, more and more increasingly, I try to design actually procedure of construction rather than the final outcome, that are somewhat informed early on in the design process by ideas of structure, principle of structure, and material properties. So this little prototype is 4 meter high by 4 meter in diameter, trying to revisit a quite famous archetype, which is the mushroom column. And it's doing so by using geotextile as the main formwork element. So you have 3 intersecting legs that somehow capture an aperture in the middle. The prototype is cast upside down to make full use of gravity and idea of pressure with the material, and then once cured, flit back in its intended position. The picture above is what we took with us in Dongguan, this large precast plant. The idea is to try to bridge academia or teaching in a studio environment with industry. So we literally, with students, took residency in this plant for 3 weeks in the summertime. My approach towards this type of work is incremental, is empirical. I like to work by trial and error. So failure is actually a part of the process, especially at the beginning, and trying to incrementally arrive to something a little bit more defined. So working at an incrementing scale. Starting with the slab, all those cables are basically trying it's to hold pressure once it's cast. The reinforcement cages built on site. So with students, we basically participate in the whole construction with all the different kind of building trades during this fabrication process. The stretching of the lathe on the temporary framework, the casting process, and the curing. And at this moment, and up to this point, we didn't know actually if it was going to work. 2 rotation in basically 7 tons of concrete, placed back in its intended position, and ready to be shipped. So this led to a second project, having worked in this factory daily, understanding how such plant operates, the kind of cycle of production. I started partnering with some of the engineers there in developing an R&D project called Osmi Tender. It's a total precast cell system. It's a little bit more of a sober project. It's trying somehow to respond to this condition of shear repetition by bringing individualization in the chain of production. So that's an image of a 40-story topology. And it proposes a series of catalog variants from one primitive, from which future residents are able to basically decide on the extent of their living. And this ultimately make up for the overall identity of the building. So it's basically trying to rethink those steel molds. You have like daily being assembled and deassembled. You have all these kind of interchangeable plugs that can vary and basically produce a variable output based on the size of openings, location of openings, length of balconies, and those makes those catalogs. So we developed fully with all the construction detail the first 9 small prototype, and now we are seeking funding for a 3-story mock-up in the yard. Back to so this basically is further speculation, a little bit more speculative than what I just showed you. It's a little bit more sober, trying to kind of like exploit Hong Kong's precast tradition. And I'm trying to kind of rethink ideas of structure with these prototypes. So what they do, they somehow, that's the point of departure. The generic column slab building that you see everywhere in every culture, at every building scale, which once upon a time had a social agenda, which was in the individualization. The idea that the architecture could be dissociated from the structural imperative. It created an empty plan, a free plan that is dissociated from the literal ground, a multiplicity of new grounds which special organization would not need to be the same anymore. And maybe that condition doesn't fulfill so much its early assignment. So what those columns are trying to do is to revisit some of the language, the grammar of some of the figures you see on the left, which I call the structural rationalists, which at the time are trying to push to the limit through an empirical process. What could one do with mainly concrete? So the way I work is trying to stretch as much as possible the prototyping, the physical process, and trying to tease out discoveries within that process. So working again incrementally, those are all tests before one can arrive to a more mature situation. Along the way, a lot of drawings, I don't have time to go through all of this, but a lot of drawings are being produced that begins to interrogate some of the geometry, guide some of the geometries. There's also a lot of environmental study. They're trying to respond to a subtropical climate. And further down the line, drawings that are becoming a little bit more speculative, or how they can be organized as basically housing, all the way down to the living units, and what kind of like other type of special organization do they create. This is where I place a lot of the effort and the focus. It's in the conception of the mold, and I have very little to do with concrete. Actually, I use quite a high grade of materials. Different materials are coming together. One recurring theme maybe that I can speak a bit about is where you see those 2D profile. Something I like to liken at the moment to stereotomy. Philippe Delorme's invention of basically using projective geometry to guide the stone cutter in the carving of a block. So you see, this is what I extract from the digital, very, very simple information, 2D profiles that are being placed together into a carcass, into a framework, from which I interpolate with fabric the remaining 3D geometry, maybe material computation. And once that's stretched, this gets hardened with epoxy, and basically it becomes a fiberglass mold, bypassing more cumbersome processes like plaster mold or CNC mold. So you see some of the example of some of those molds as mock-up, as test, and as final molds. So let me say just a few words about each column. Column 1 kind of draws from Candela's shell saddle surfaces, timber formwork, and so it uses a stack up of ipars. I mean, the idea is to transpose a lot of those language, which are mainly single stories, horizontal, into an idea of vertical living. The question was how to perforate the shaft of a column while somehow maintaining a bit of a structural integrity, using ipars and the stacking of ipars as a way of demarking a public ground at 1 to 100. Column 2 is a drawing from the estate and the idea of corrugation. A corrugated wall as a delineator of the special organization of those spaces. So it's also a drawing from Nervi. It's splitting both upwards and downwards to receive an irregular ground. All those bases are abstraction of ground condition that one can find in Hong Kong, an hostile topographical ground. Column 3, 4, and 5, they rethink the idea of like courtyard housing. In this case, it's a bundle of 4 pencil tiles that also split at the bottom and at the top. A lot of this geometry is based on environmental studies and light penetration. Column 4 is a shoe horse as well, with a lot of channels going inwards and further inwards into the thickness, whereas more solar gains as a way of like creating shading. Column 5 is using a quasi-periodic tiling, very few elements, only 6 molds to make a field of 49 elements that can combine in different ways, creating a seriality of voids around which neighborhood community could be organized. And this is all individual tiles, actually, they work by friction as you assemble them, so kind of building blocks. Column 6 is drawing from a Frioto high and low point tensile membrane and trying to reinterpret them into a series of interconnecting shear walls, frontally opening to light and transversally opening to air. Column 7 is rethinking Maillard mushroom slab structure, flaring both upwards and downwards, upwards to receive the ceiling loads and downwards to distribute soil pressure, and is rethinking as a bundle of like cylinder element of various periodicity and density, so it's a very porous column, as a way to agitate basically the horizontal slab. Column 8 is drawing from Nervi's changing profile columns, also towards the top, creating very deep shaded spaces. They're about 1.8 meter each. And column 9, which I just finished last week, or a few days ago, with this idea again of like terracing within a point block tile, both downward stairs and upward stairs. An idea of rendition within an urban context and trying to contrast like again the kind of skeleton framework that basically populates city, and also trying to think of them as a way of reframing a city. Column 1. The last section is something I've been embarking on recently. It's a fascination to the straight line. It's called line on fire. The idea of a line moving in space to describe some of this geometry. We'll get back to this tool. But it's a mold making machine that we constructed in school with a former student named Victor Long. It's basically it's a 5-axis hot wire cutter machine, 4 translation, 1 rotation. We did a lot of like parts from chefs in Shenzhen. And it's again thinking of stereotomy is the idea of the slicing of a block, but this time internally. And as this block gets sliced, the part gets pushed apart and one cast in between. But this originated from this series of projects you may have seen. I've done with a colleague of mine in HKU, which is also defined by, basically they're all rule-based geometry, defined by changing a moving line in space, the pinch, sweep, and warp, a series of 3 timber structure, very low budget, it's like 100 HKD each. They all have very specific site response and small programs, in Yunnan province, in basically villages after the post-earthquake reconstruction efforts. But what I wanted to speak a little bit more constructively and geometrically. So the line is basically, the moving line is trying to be arrested by a sequence of trusses, evolving trusses. So in the case of the pitch, starts with a small door and evolves towards a pitch roof, underneath which we've located in a library. The sweep is organized both radially and tangentially, brings people progressively up and down, and the warp is organized longitudinally. We use the same carpenters for each project, 1 wood section only, it's like 11 cm by 3.3 cm thick. So it's the idea of trying to articulate those new grounds as roof, active grounds, with straight timber element. So the idea of like, you know, the whole concept is through that surface, The space is activated above, as you just mentioned, as a new ground, and the space below is also activated through the articulation of the ceiling. So the literal ground is just a down flat slab, but the compression expansion of the space is through the changing trusses. The pitch also acts as a bridge between the main village and the plaza below, and as a library underneath where all the bookshelves are suspended from the truss. The sweep viewing platform is a play area for a school, the boarding school that is just around the corner. Brings people up to a certain datum to see this pretty amazing landscape. This we build with students. We take 65 year 2 students for a week during reading week, and there's a bit of pre-cooking and prefabrication involved, but we get them to participate in the assembly of the project, putting all the pieces together. And this is the last iteration finished last year, the warp. Again, space below. It's a famous spot where people stop along the road to see this amazing open valley, and we're asked to try to generate something also with a bit of an economy. So the step you will see in a minute in front act as a roadside market, so a bunch of vendors are selling food. So back to the line. Those are things I've been doing recently. I don't actually design it, so they're all molds. They're all part molds. You put them together. There's a gap in between. There's a 4-pin shell concrete. It's at a very early stage, but I don't actually model any of these surfaces. I just give them protocol of movement and time. So it's all about working from the machine, basically telling the machine how to move and at which speed, and then you have all this kind of different topology that begins to emerge and would be a bit difficult to just design. Some of the tests. So this technique was being used to create column 8 and column 9. So you see the changing profile, taxonomy of plugs that gets put together and basically cast in between. And column 9, the same thing, but horizontally in there, there's a time factor. That's what you see on I don't have a photo here. But it's very compressed at the bottom and kind of expands as it goes to it. So some of the modes. And those are things that are on my desk at the moment. I work that way. I'm not fully sure what it's good for, where it's going, but basically they're trying to explore some of this emerging geometry in like baby steps. So you progressively guide it as it goes along. So all the species makes a block, so they all interlock together and comes apart. So that was my last step.
Thanks very much, Olivier. I think you've already helped us make the transition from concrete to timber. I should mention that Mark Goldhart is also a founding partner at Mark & Chantal, which is a multidisciplinary design firm based in Hong Kong. It's doing everything from branding to interiors to architecture, and Wawa is sort of the embedded research and exploration laboratory in the same office space. So please join me in welcoming Mark.
Thank you, Jason. I am Herman Miller's showroom. I will go through the presentation and then you see what. So, I'm not the digital guy. I'm the guy who was a carpenter and happened to meet Roberto D'Avoglio, who is now in the factory in China cutting wood actually. I met him there, not on the bridge. We went there and we had several days, a week or more, in the middle of the Himalaya with all these really nice mountains around us to discuss a bit what can we do. We passed 40, we have a bit of money in the bank, and that's like, okay, we can continue to do the same as we were doing and maybe pile a few more dollars in the bank account, buy one more flat, maybe a Ferrari, whatever you want. We decided, well, why don't we do something else? And it all started there because sharing the room, sharing the meals, the walks in the Himalaya and so on, just fresh air, gave us a fresh approach to our life. So what you will see after that is a slow evolution that is continuing now from that point in time a few years ago. Just one more slide to make you envious. And we decided to work with one material. It's extremely important. I'm going to go through a few slides about that. We want to work with timber. That's a Chinese say that we have on one of our cups in the office, so we put it in our presentation. We think it's time to also try to contribute to changes in the world. So we believe in what the two previous presenters do, exploring technology, new discovery, but also would like to work with materials that can grow and be sustainable. So this was a very important choice at the beginning. And that's what we are. We are craftsmen and innovators. I'm actually a carpenter. From the age of 15 to 20, I did an apprenticeship, and then I moved into design, and I have a lot of people to sell what they do. Part of them are developers, so I tend to work with a lot of architects, and I think that was the bridge with that. But we also believe in technology, we believe in innovation, and we think this is really important for us. And I think the talk tonight revolves around that. And we understand economic, but we also look at social scale. It's important that whatever we do, we think about who's going to use it. And we understand the necessity that it's also economically viable. We do not intend to become rich from that. But I think this is becoming more and more prominent in the world. We also think that a lot of people want to live a healthy and natural life. And therefore you want to try to create habitats or places that where you feel good and that are built in a proper way so that they have a good impact on your life. Another little thing we looked at, that's what we're calling. So these are figures in 2012. They must be even worse today. You can notice the last 2 or 3 months the weather was not really good, and the pollution during the year changed a lot. We also want to contribute to using material rightly so that the planet start to use less material, and consumerism is based on different values so that we can all live on this planet properly. That's why we believe in wood. It has a lesser impact in terms of economic energy, and it's actually, if you take the full cycle, it stores carbon, it grows, it's reusable compared to other more traditional materials in the construction industry. We also know that deforestation is a big thing, and it contributes to a lot of this global greenhouse. And we use only material that come from renewable sources. We have a strong collaboration with the largest privately owned forestry in Europe. And these guys have been sustainable for 150 years. And that's due to the country law themselves. But they take it for granted when the rest of the world don't even talk about it. So it's very interesting to work with them, and I'm going to go back to this at the end of the conversation or the talk. I know you talk about other materials, sorry. We think this one is the most important. But bamboo is natural, concrete maybe less. It has its own property that are necessary. But we love wood because is natural, is reusable, it's recyclable, it's sustainable. This is one of the nurseries where most of the timber we use come from. They grow 100 million trees, not trees, 100 million seedlings a year, out of which, once planted in the forest, on average half are growing to full trees. So it's quite a large number of trees that they plant. And as I mentioned earlier, we only work with materials that come from certified sources, even if it costs more. It's extremely important for us. Wood, like other materials like bamboo and stone, have been used in the past, but can be used today to generate contemporary architecture, revisiting the way we live in a modern society as today. And here I'm going to go a bit more into the technical. So we think that the environment is important. So we are two things. We are craftsmen and digital developers. So my partner, Roberto D'Avoglio, used to help architects and designers to realize their complex shape structure, a bit like what Martin was in Macau. And I'm coming from the other side. I'm coming from the workshop where we cut timber. So I'm the guy who said to Roberto, it will hold together like this and that, the joint should be like this and that. Roberto is the gig that makes the process parametric. So all what you see here is not 100% parametric, but I would say at least 90 to 95% parametric, up to the detail. So we'll go step by step into it. But what's important also is to look at the situation where the structure is based, like you are looking at the wind load, same for us. In this case, it's more about the sun, because it's a shading device, and a bit of the wind flow. We also like to see where is the strength from the weaknesses of the structure. So it's not integrated in each one of the projects, but we try to get to that later, where we can test an early sketch at an early stage for its strength and weaknesses, and act on the design at a very early stage, not doing the reverse process, designing everything, getting Arup or somebody else in, and say, make it happen. And they put a big column in the atrium. I don't want the column in the atrium. Too late, guys. So we believe in talking about how things are built and how they stand at an early stage. It's important. Some of you know about parametric design. This is something that Roberto did, I would say, 12 years ago. So for some of you, it's very old. Maybe for some others, it's new. What it's showing is that Roberto is changing a skin structure. And almost in real time, you can extract the information for each change. So that's something that's happening today in the industry. I mean, I was talking with Martin, he just produced, I don't remember how many thousands of drawings on actually cutting files for a project in Macau. But that's where people start. It's how to extract information for the construction of something, a building, an object, in real time, and even give it different materiality and all that. This is today quite a simple thing to do, as I've been told. I'm not able to do it myself. But you can extract, each panel can have a different shape and all.